Example 2. Find the degree measure of theta if it exists. Do not use a calculator. All right, well, if you look at part A, we are trying to compute theta equals the arc sine of the negative square root of 2 over 2. So this type of problem looks very similar to what we did in example 1, and it is. The only difference now is we know that these inverse trig functions return an angle. Now we need to state the angle in degrees instead of radians. That is the only difference between examples 1 and 2. Okay? All right, so let's look at this one in part A. Again, we're trying to compute the arc sine or the inverse sine of negative square root of 2 over 2. So let's go pay a visit to page 7. We need information on arc sine, okay? So we know that the domain of the inverse sine function is negative 1 to 1, and the range is from negative pi over 2 to positive pi over 2. Okay, so I'm going to jot that information down here. So the domain is from negative 1 to positive 1, including the endpoints. The range is going to be, well, the range, remember, these are the angles that can be returned. Okay, so what's going to be spit out is some angle between negative pi over 2 and positive pi over 2, endpoints included here. Okay. All right, so when we look at this, okay, let's translate it, okay? Again, the arc sine is going to return an angle. So the arc sine of negative square root of 2 over 2, this is going to be the angle between negative pi over 2 and pi over 2, whose sine is negative square root of 2 over 2. Okay, so that is what we're looking for. We're looking for an angle between negative pi over 2 and positive pi over 2, whose sine value is negative square root of 2 over 2. Okay, let's head to the unit circle. Okay, so bottom of page 7, we know for inverse sine, we need to be using the right-hand side of the unit circle. The angle that is returned is between negative pi over 2 and positive pi over 2. That range corresponds to quadrants 1 and 4. Okay, so since we're looking for a negative sine value, sine is negative in quadrant 4, it's positive in quadrant 1, so we need to concentrate our efforts on the fourth quadrant here. Okay, so let's see, I'm going to erase some of this previous work. Okay, so when we look at this, okay, and we're looking at quadrant 4 here, okay, the sine value is going to be the y coordinate. Okay, so we need a y coordinate of negative square root of 2 over 2. Okay, here it is. Okay, and so then we have found our angle right here. So there we go. We need to state it in degrees, so that would be 315 degrees. However, you've got to make sure that the angle you spit out is in the correct range. Okay, the range here is written in radian form. Okay, so if you convert this to degrees, the range is going to be negative 90 degrees to positive 90 degrees. Okay, so even though the angle here in the fourth quadrant is 315 degrees, we need that number, we need the degree measure to be between negative 90 degrees and positive 90 degrees. Okay, so 315 degrees is incorrect. It is the correct location on the unit circle, but by definition, we have to return an angle between negative 90 degrees and positive 90 degrees. Okay, so if you think about this, think about your angle starting with an initial side along the positive x-axis and then just rotating in the clockwise direction until you get here. This is going to be negative 45 degrees. Okay, you can also see it by taking 315 degrees, okay, the spot we landed on, and subtracting 1 revolution, which is 360 degrees, that's going to give you negative 45 degrees. Okay, so the correct answer here is going to be negative 45 degrees. Okay, again, if you put 315 degrees, it is technically incorrect, even though 315 degrees and negative 45 degrees are coterminal. 315 degrees is technically incorrect because it does not fall between negative pi over 2 and positive pi over 2, which is the same thing as negative 90 degrees to positive 90 degrees. Okay, you have to pay attention to domain and range. Very important. Okay, let's try another one. In part B, we're trying to calculate the cotangent inverse of negative square root of 3 over 3. Okay, when we look at this, okay, we have to go and grab the information about cotangent inverse, but again, this value is going to be some angle that is being returned. Okay, so jump to page 7. Let's look at cotangent inverse. Okay, the domain is all real numbers. Okay, and then the angle that is returned is between 0 and pi exclusive. Okay, so let's jot this down. So we know the domain of cotangent inverse is all real numbers, which means we can plug in anything we want. So square root of 3 over 3 is a valid input. The type of angle that is going to be returned by definition has to be between 0 and pi. Okay, so if we translate this quantity cotangent inverse of square root of 3 over 3, this is the angle between 0 and pi. Okay, that's based on the range. Okay, whose cotangent is the square root of 3 over 3. Okay, so let's go look at the unit circle. Okay, we know based on this range 0 to pi, that corresponds to the top half of the unit circle. So for cotangent, we need to focus on quadrants 1 and 2. Okay, so if we come down here to our picture, we need to use the top half of the unit circle for cotangent inverse. Okay, so when we're looking at this, okay, let me erase some of this previous work. We now need an angle whose cotangent is, so we're looking for the cotangent inverse of square root of 3 over 3. Okay, so again, we need an angle whose cotangent is the square root of 3 over 3. Okay, remember when you do cotangent, that is the x coordinate over the y coordinate. Okay, we are dealing with quadrants 1 and 2. We have a positive value here. Square root of 3 over 3 is positive. So cotangent is positive in quadrant 1, not quadrant 2. So we're going to concentrate on quadrant 1. Okay, so look at these values, kind of scan the XY pairs. Which one of these guys is going to return, if you do the X coordinate over the Y coordinate, which one is going to give you square root of 3 over 3? Okay, well, let's see. If we look at this, my guess is it's going to be this one. Okay, you might want to try out pi over 6 too. It's between those two, but if I do the work in my head, the x coordinate over the y coordinate, I think it's going to be this angle here. Okay, so let me check it out. If I do the x coordinate, that's 1/2 over the y coordinate, which is the square root of 3 over 2. This is going to give me 1/2, change to multiplication, flip the bottom fraction. And so now the 2's cancel. This is going to give me 1 over the square root of 3. And then if I rationalize the denominator, multiply top and bottom by the square root of 3. This is going to give me square root of 3 over 3, which is exactly what I'm looking for. Okay, so the correct angle here is 60 degrees or pi over 3. Okay, we need to return the angle in degrees, and so the answer here is going to be 60 degrees. Okay, so that is the answer. 60 degrees, also make sure when you return it, it is between 0 and pi. Okay, and if you convert this to degrees, pi is 180 degrees. Okay, 60 degrees is in that range. Okay, remember, if it wasn't in that range, you'd have to find something coterminal with it. Okay, that was in that range. Okay, but 60 degrees is the answer here. Let's do one more, because essentially we're doing the same thing. We're just returning a degree angle instead of a radian measure. Okay, last one, we are going to compute the cosine inverse of 2. Okay, so what we need to do here is write down domain and range for cosine inverse. Okay, so back to page 7. When I look at page 7 here, cosine inverse has a domain of -1 to 1 and a range of 0 to pi. Okay, so here we go. Let's write this down. Domain, you can plug in any number between -1 and +1, including the endpoints. The range is going to be, the angle that will be returned will be between 0 and pi, inclusive. Okay, so if we write this down, this is going to be the angle between 0 and pi, whose cosine is 2. Okay, so since the angle that is returned is between 0 and pi, that corresponds to quadrants 1 and 2. Okay, that's the top half of the unit circle. Okay, so if we go back to page 7, we know we need to use the top half for cosine. Okay, and cosine is associated with the x-coordinate. Okay, so you want to look in the top half of the unit circle. You're looking for an angle that has a cosine or an x-coordinate of 2. Okay, so when you scan this, nothing on the unit circle that is emphasized, none of these called out angles has an x-coordinate of 2. Okay, so it could be something else. You may have to use a calculator, but again, before you go that route, you need to check the domain. Okay, what are you allowed to plug into the cosine inverse function? Only inputs between -1 and +1 inclusive. Here, you're plugging in 2. 2 is bigger than 1. Okay, so 2 is not in this interval, -1 to 1. So it is not a valid input. Okay, 2 is not in the domain of cosine inverse. Okay, so what we can conclude here is that the cosine inverse of 2 is undefined. That's it. We're done.